So hello and welcome to the introduction of Google Earth Engine and the type of things that we are going to be doing with Earth Engine. So I'm going to give a brief overview of what this cloud computing platform, that is Google Earth Engine, stands for. And essentially, basically what we would do in Earth in QGIS or ArcGIS was limited to storage and computational power, where we have to download huge tiles for the analysis of a single image, and we have to work with limited specific areas. But with Google Earth Engine, it is now possible to work with multiple images as a image collection uh, at the same time, creating time series analysis at a global scale. If let me go to the website. If we type earthengine.google.com, we can see this is the homepage of Google Earth Engine that says this is a planetary scale platform for geospatial analysis. Um, it provides variety of applications. Number of applications of Google Earth Engine is absolutely enormous. There are also case studies that we can see in their website for how they have used the Earth Engine, from the forest cover changes to there are many that you can look. We are going to look at what kind of data sets they provide. So in the data sets, they have categorized the data like atmospheric, weather, imagery, and in imagery they have many like Landsat, Sentinel, and MODIS. If you go to the Landsat, uh, we can see they provide surface reflectance product of Landsat 9 that is now available in Earth Engine. Landsat 8, Landsat 7. Let me go Landsat 8. That you can see all the details, all the overview of Landsat 8 level 2 product. It shows the availability of data from March 2013 to till now, and provider, that is USGS, of course. And here you can get the Earth Engine snippet that we can put in the code environment of Earth Engine to call the data set. Here you can see the description of the data, and in the bands you can see the resolution and the name of the bands, what is the name of the band stands for, what the wavelength and the scale. So if we go back to the web homepage, that you can see that it provides API in both Python and JavaScript. If we will go in the code environment in a while. This is how it looks, the GE interface. So first of all, if you don't have any account, you have to sign up from here. I have already signed up, so it is showing my email address. But if you have not signed up, you have to provide details, and they will confirm within a day or so. So this is the code editor. Once you get signed up, this is where you spend most of your time. So let me introduce, this is the Google Earth Engine interface. So here we have the map. Here we have the map, and these are the geometric tools where we can draw rectangle, polygon, or point like we would do in QGIS. Let me delete it. And in the right side of the map, we can see they have provided satellites and map. Once we have add a layer, it will be shown here. In the our part, we have first in the left hand side, it is The script side where we can save this, save our codes, it shows here. In the document parts, it shows the different features and algorithms that we can perform in Earth Engine. This is the assets that we upload shape files in the Earth Engine. It will be shown here. This is the middle part of the code editor where we write the code. Like let me print hello world, and if we run here, we get the in the console part we will get the result of our code. From the inspector tool, we can check the layers and coordinates and the details of our points. Like if we get the inspector and click here in New Delhi, it shows the lat long and zoom level, scale, and if we had any layer, it will be shown. It will be shown the values here. We don't have any right now, but let me now let me show the data sets first. What kind of data sets they have? In the data sets, they have many type of data sets, including Sentinel, Modis, and not only the imagery parts, they also have geophysical data like DEMs of SRTM and land cover of Modis, that is a product they provide, and cropland data that is only available now for Canada and US, and VIRS Night Light data. But for example, if you want to work with Landsat 8, we will import it from here. If you want to work with the Landsat 8 surface reflectance product, we'll go here. And I already explained the description of the Earth Engine. These are the bands. And if we click on this link, we will go to the example dataset of Landsat 8 surface reflectance product. It will be shown in a while. Here it is. So what they have, this is an example, of course, but if there you can see they have declared a variable called dataset. We can change it to any name. This is only a variable, and this is the calling function of Landsat 8. This is the ID, and this is the calling feature of Earth Engine, that is e.image collection, and this is the ID that we will call. Here you can change the ID, and this will call another product. And we have filtered this data set that because this is a data set of last 10 years, but we don't want that much data, that much images. We will filter out within our date. That is, we can change this date, that is in format of YYYY So if we change, let's suppose we want to work for December 21 to December 31. So this is the scaling factor that we have to provide, and that you can see in here. This is the scaling factor. After for the visualization part, here we have provided what kind of bands we want to show in the code environment. We have centered the map with this lat long. We want to change this lat long, so our map will get centered in the New Delhi. Or let's suppose we want to go with the Bhopal. Here is the lat long of the Bhopal. We will copy it from here and paste it. and this is the zoom level. This is that long, and this is the zoom level. And for the mapping in the map section of the code editor, we will have to provide the map.addLayer function, and in the add layer function we have to provide the image that we want to show, and the visual parameters that we want to show, and the name of the, we can change this name to any name that will be written in the single quotes or the double quotes. Let's suppose we are writing Landsat 8 only, and what this visualization is that we have provided the to show band 4, 3, and 2 bands, and minimum values and the maximum value. If we go to the run, it will be showing in a while. You can see this is a cloudy image from here. Let me change the date to 11 30. Run. We'll zoom in our study area, and we can see the Landsat 8 image here. This is very quick approach, and this is the band that we have setted for 432. And if we go to here, this is the layer toolbar. If we go here and click on the setting, we will see the red, green, and blue bands. We can change it from here. For let me change 4543, and this is the range. We can stretch it to minimum maximum values, that is stretch 100%. We want to work with stretch 90%. You can work with any, and apply, and this will give the image of false color composite of Landsat 8 surface reflectance, that is band 5, band 4, and band 3. We have stretched it to the 98%. We can stretch to the 100%, or we can put the minimum maximum values as a custom. That is stretch is approx 0 to 0.3, of course. And here we can see the vegetation, and you can see this is very quick. But let's see that this is the image of at a global level. If we zoom out, you can see that we have mapped the Landsat 8 false color composite for the whole global. That is why it is taking some time. It will take some time to load all the tiles for the area. Now, if you want, it will take some time, but if you want to perform within within our small study area, we can do it very easily by this. First of all, let me uncheck this layer, and let's suppose we only want one tile in the Bhopal area. So what we do, we will either create a polygon or a point. I'm going to create a, let me create a polygon. You can upload your shape file also from here, new, and upload your shape files from here, CSV files. But from for now, I'm only working with geometry. So I have created a geometry over Bhopal, and I want the tile for Bhopal only. I don't want at a global scale. So, and as soon as I have created a geometry, it is shown in the import section that we have created a geometry name, variable name geometry. I can change this to any like region or AOI. I can area of interest. I want to name it And in the filter section, like we have filtered with the date, we can also filter bounds, that is dot filter bounds. And from what boundary we decide, that is we had AOI, that we have created a polygon, and it will give the tiles that only uh, connected with Bhopal. And if you click on the run, you can see that it gave only 2 tiles that is connected with the Landsat. And if you zoom in and uncheck this, now we can see that we are working with Landsat 8 image. For making it for false color composite, we can also change it from here also, or from the here, like we did previously. 5, 4, 3, like, and this is our false color composite, but we don't want from here, but from we can change also from here. That this is the band name, band 5, band 4, sorry, band 4, band 3, and run. And we'll get same image that we have worked with, like visual parameters. We have changed from the visual parameters. We can also perform from here also. But let's suppose we don't want whole tiles. We want only uh, clipped image from within our geometry. So what we do, we don't need filter bound. We need a clip function. So I'm using clip, and what clip function do, it will create the Landsat 8 image only within our specific area that we have created. So if we click on the run, it is giving an error that says that clip is not a function. This is an error because we are working with the image collection, and for the clip function we have to perform for a image only. So to make an image, we what we can do is we can reduce it either with mean or median or any, to make it a image collection to a image. So I'm creating a mean of November month of 2021, or I can do it a median. And now clip function, it should work now. Okay, let me delete scaling factors. Uh, we zoom in, and maybe some minimum maximum values are not correct. So we can stretch to the 100%, and we can see that we have stretched to 100%, and we can see now that false color composite has been mapped only for our specific area that we have created. For the export part, that we don't want to work from now on this Earth Engine, we want this image to the QGIS or ArcGIS or any other software. What we can do is we can export to image to drive, and here you can see that what parameters we have to fill, like control space. These are the parameters we have to specify. Note all are mandatory. We can see from here that this is the mandatory and all others are optional, like the description is optional, folder is optional. Let me, we want to image that we want to export, like we want to export data set. Description, what we should add, Landsat 8 false color composite. Folder we want in the root. I don't want to add folder, or let's create a folder name. Export from export only. Let's see. File name prefix, we don't want to add it. Dimensions, we don't want to add. Region, we don't want to add. Scale we want to add, like what the scale we of image we have. We have a scale of 30 meters, so we write 30, and all other we don't want, so I'm deleting. And if we click on to run, or we have to this also, and if you click on the run, in the taskbar you can see that a task has been added. That it says Landsat 8 false column body, that is a description of our image. And if we click on the run, name is not in the format, now it is in format, and you can see that scale we have 30 meters. In the folder export or any other folder, GEE export, we can write any folder in this, will be export in our Google Drive. And file name we can write, we will write same Landsat 8 false color composite, and this will be in the format of geotiff. So if you click on the run, this is how we export, and once it get completed, it will be shown in our Google Drive. Here you will see your image once it get completed. It is working. It will take some time, so until we can explore the Earth Engine website, earthengine.google.com, and there is a FAQ that you can read for the information about the what is the Earth Engine and how it has been created, like these stuffs. And in the platform you can see the documentation part. Those who don't have a coding background, you can go through the APIs tab from here, and they have created a very nice documentation for their API guide. You can learn from what kind of functions you have to perform for, or what, like for the image functions, what we will work with the raster in the Earth Engine. For the image collection, it will give a stack of images. For the geometry and features, what kind of other features you can see from here. And you can also get the practices, the very nice documentation that they have created for those who don't understand JavaScript, or the you can learn from here. A very nice documentation how to start. Once you get familiar with the JavaScript and Python API and how to use the functions, you can start using the Landsat. Start using the working with Landsat or Sentinel or any other images that you want. Now let's suppose we want to create a DEM. So let me delete first. Let me create all the clear script. And for here you can search from the either places or data sets. So I'm searching SRTM dataset, SRTM 30-meter dataset of digital elevation. Here it is. And if we click, it will show the same thing about the dataset availability, and who is the provider, what is the code snippet, and if we click on the C example, it will give a sample example in the code editor. We give the description. Here is the bands. It has only one band, that is called elevation, minimum and maximum values, and resolution. So for the importing in our code editor, either you can import directly by clicking on it, or you can copy it from here and paste in the code environment. We don't want to paste, and just we want to import. So just import it and name it. You can give any name. I'm giving it SRTM, and you can see that there is a variable name SRTM, and it is now a product that we have imported in our Earth Engine environment. Now we want to filter it by selecting the band we want to work with. So we have to declare a variable name, let's say filtered, and we want to work on this SRTM dot dot select, and the bands we want to write what kind of band we want to select. It has a band name elevation, so we write it here, elevation, enter. And for the mapping in our map area, we have to write a map function, that is map dot, and we want to add a layer, so add layer. What image we want to display, that filtered image. What is the visual parameters that we want to give? Visual parameters we will give in the curly brackets, like minimum maximum values. We want to give the minimum values, let's say 0, and maximum values elevation we want to give, that is 3000, let's say. And after closing the curly brackets, we can write the name, or this is an optional, we can perform from here also, but I want to add a name of this layer. We will give this DEM. So this is the name of the layer, this is the visual parameters of the layer, and this is the image that we want to add in the layer. And if you want to click on the run, it will give DEM at a global scale within the range of 0 to 3000. Now, like that we have said that we want to let's say we want to work with only uh, a specific area, so let me disable it and zoom into the Bhopal area, and we want to check the DM for only this area, so we'll create a polygon. And in the filter section, what we can do, we can filter this data, that is filter, and create a bound within our geometry, that is name variable is geometry. Let's say the geometry, we want a bound in the area. So, and now if you click on the run, okay, we don't create filter bound, we will create a clip function. Now if you click on the run, it will give the DM within the geometry only and within the range of 0 to 3000. Let me reduce it to the 1000. Now it should be clear now. And you can use, and if you want to see this in the colors, you can create a palette in the visual parameters that are in the curly brackets that we have here, and you can write palette, and within the palettes you can write name of the colors or the hex values of the colors. I'm writing the name, let's say purple, white, and what we can do, green. Yeah. You can write any colors or the hex values from there is sorry, colors, color palette. color palette. If you go to the color palette, page cancel and go palettes. Either you can get name the colors or the hex values of the colors that are. Let's say you want to visualize this DEM data in the color palette of this. So or this. So we will write this code, this 60 code within instead of using purple or anything. If we go to the run, you can see that it has given the DEM within this range with our color palette that we have provided. You can also click from within the layers in the settings. This tab, it shows the visual parameters. Uh, you can stretch it to the minimum maximum values, that is 423 to 601, and you can also change the color palettes that you want to add another palette. You can add it from here. You can add another layer. Any color palette you can add. Like this, you can add, and you can also modify the minimum maximum values. You can stretch it to the 100% or the 90%. That will cut the top 10% and bottom 10%, and it will give this image. This is the opacity. This means the transparency of the layer. You can see that is now layer that is being transparent 50%. We will normally work with the full opacity like this. So you can add any color palette like this. So, and from the inspector toolbar that we have discussed earlier, if you click on this part, you can see that it is showing the lat long of the image. It is showing the elevation, that because we have added a layer, so it is showing the elevation and the zoom level. So like this you can also perform. Now let's suppose we want to work with NDVIs. Okay, let me first delete it all. We want to work with NDVI. So here we type the NDVI, and we can see that it is not showing. Okay, we can see that Modis provides the NDVI product within the Earth Engine itself. That is a Modis 13A2. That is the ID name. So if we click on this, either at the 250 meter resolution or the 1 kilometer, you want to work with this. So you can check the description, you can check the bands. It has uh, 3 bands. First is NDVI, second is EVI, and third is quality bands. So we want to work with NDVI band. So first we have to import it and name this variable to, let's say, modis. And because this, you can say this is the data from year to 2000 to till date. So we don't want that images. We want to work with only, let's say, last year. So for modis, we want to filter the data. So filtered, or anything you want to say, like modis filter, anything that you can name. And we want to work on modis and filter date, and you can check that we have to give what kind of parameters that we have to give. We have to give start date and end date in the format of this that you can see. So we want to give this filter date, feature, and 21, let's say January 1st to January last. You want to work. Okay. And let's say we want to work with, or let's say Bhopal we want to work. Okay. So we'll create, uh, again, we will create a geometry. Let's say we will now create a polygon. So here we want to create a polygon over the Bhopal. You can create a rectangle or anything. So this will create a variable of geometry within the import section of the code editor, and you can use the cliff function for the geometry. And before the cliff function, we have to convert this image collection that you can see that this is the image collection. For converting it from image collection to image, we have to reduce it either with the mean or the maximum values or the minimum values of the NDVI or the median values that you can check from the document section, that we can see reduce and image reduce, and you can see this type of image collection. And for the image, to reduce the image collection, we have these types of reducers like median reducer, max reducer, mean reducer, minimum reducer, or anything like that. Some we want to add mean NDVI of January month, and after that it is now a image, and now you can use the clip function. We have created a clip function for the geometry, and now we want to map it on our so mapping, we have to add a map, and we want to add a layer, so add layer. And what kind of, sorry, first we have to provide the object that we want to show here. So what object we want to show? We want to show the modis filter object. So we will we will type modis filtered, and visual parameters that will give in curly bracket that I have discussed earlier. In the curly bracket, we have to provide the minimum and maximum values. What is the minimum value of NDVI? -1 to 1 or 0 to 1 in the case we want to work with, max 1. And we can type bands because we have seen that this product has 3 bands. We want to work with NDVI only, so we'll type bands, and here you can type NDVI. If you want to add a color palette, you can add color palette also in the, let's say, yellow and green. You can type any color you want and as many colors as you want. There is no limitation. It will give the minimum to the yellow, maximum to the green, and if we had any color within, it will interpolate within the range. And the name of the layer it is asking, you can, this is an optional, these all are the optional opacity shown, but if you want to add, this is your choice. I can add name NDVI of Bhopal, and show opacity I don't want to add, I want to give this any, so I am deleting it. We can run. So is not showing correctly. That is because we have provided the minimum value 0 and 1. And if we go and check the data set, if you see the product, you see the band, it is within the scale, and the bands, where is the band? Here, and you can see the scale that is had been scaled to 0.0. 0.0001, and the minimum value is minus 2000 and maximum is 10,000. Either you can multiply here, either you can multiply from the scaling factor, that is 0.0001, and click on the run button. That will multiply the NDVI values. Either you can do like this, or you can change the minimum maximum values from 0 to, let's say, 7,000. In the scaling factor, that will be equivalent to 0.7 NDVI. And if you click on the run, it will show like this. You want to perform like that, you want to work like that, multiply to the scaling factor, that is 0.0001, and the done. Wrong, we have got 7.0001. Like this, let me go to the visual parameters and stretch it to the minimum maximum values. Now click on the run. Now it is correct. We can stretch it to the minimum maximum values and we can get the image. You can see that image has been already clipped to our polygon, and this was our polygon, and it has been clipped because we have used the reducer, that is mean reducer, and used the clip function for the geometry, that is this polygon. And we have multiplied with the scaling factor. Either you can multiply or you can change with here minimum maximum values. You can select the band. This is the band that you can see the visual parameters. It is showing the NDVI bands. You can either check the EVI band also, because Modis, this product of Modis provide NDVI and EVI, that is enhanced vegetation index also. So you can work on this also. We want to work with NDVI, so NDVI and select. From the inspector toolbar again, if you want to check the values from the specific sections, let's say we want to check for the section. Here we want to check the NDVI value. If you click on this point, it will give the lat long again, zoom level, scale, and the NDVI values. And because it has EVI band also, it will give the EVI value also. So if you didn't want to work with the geometry and you want to work with the global level, you can delete that clip function. You can delete the geometry and click the run. Oh, sorry, we have to reduce to the, we have to use the reducer also. We can only, we deleted only the clip function and the geometry function. And you can see now, that, let me zoom out first from the map. And you can see the NDVIs of the Modis product for the global level. You can stretch it from here to the minimum maximum values, that is 0.1 to minus 0.1 to 0.8, and you can apply. Now you can see that we have added the NDVI. You can add a color palette to any you want, like I want blue, I can type yellow, brown, let's say green or yellow, sorry, brown and green, let's say. And if type, click on the run, and again we will go to the minimum maximum stretch, or you can give here like minus 0.1 you can give, because this is the minimum maximum value stretch. and 0.8 you want to give. Here you go with your chosen color palette. Either you can work with global level or with the, let's say you want to check in the Africa, what is the NDVI here? You can click here and you will get the NDVI. We have checked the NDVI within this range, within this date range. You can check, change this also. We want to, let's say we want to work with the last week. So 10th March of 2022 and to the 20th March. And if you click on the run, there empty date range, okay. It don't have the data from the March. Oh, sorry, 32. Now it should work. Again, it is showing must also cancel. Okay, we'll get the for the whole March month. We can check if it has the data. 20. It don't have 10. It don't have the data of March 2022. Maybe February it has. Yes, it has the data of February 2022. The March data will be updated in soon. And this is the NTVAL. What you can use also the export function that we have already discussed for the, let's say you want to work now with nightlight data. Let's say nightlight data. So nightlight, what kind of nightlight data we have, you can see. So you can see that DMSP nightlight data we have VIRS straight light data. You can use any nightlight data, or you can explore what kind of data. Let's say we want to add this layer, and you can say VIRS. You can name this variable anything, and now we can check the date range. So we can work. You can see the date range is from 2014 to till now. So we will filter the VIRS to the filter date within the range 2001. We want to check for the January month. So we want to work with the whole January, and we want the let's say this time we want to maximum nightlight radiance. You can check the bands here. What kind of bands it has? It has average radiance band and the cloud free coverage. But we want this band for the visualization of nightlight. And this is, you can see the unit and the minimum maximum stretch. So let's say you want to select this band. We'll see, and before maximum reducer, we can select the band, that is average radiance. This is the band name that we have selected from what we have done in the filter, that we have given the VIRS name, that collection, and we have filtered the collection for the filter date within this period. We have filtered the data set for our only band, and we have reduced the data set for the maximum reducer. And now we want to, let's say we want to perform with let's say India. This time we are going to work with the shape file, let's say. So I have the shape file of India. Here I have the shape file of India level 0. You can check this. You can say this is India, and I have, okay, what it says? No, nothing. So I have uploaded the shape file from here. You can also, if you have any shape file, you can upload it and you can work with. I have already uploaded the shape file of India level 0 boundary. Here you can get. I have imported. from the asset tab, and now I want to clip the global level nightlight data to only India. For the mapping the layer, again map, add layer, filter dataset to the minimum maximum stretch. Minimum, let's say, what is the minimum maximum stretch? We can check. Minimum maximum stretch is 0 to 1 million, I think. So let's say you want to minimum 0, maximum 10. Let's say 10 lakhs, and let's say this only we want parameters, and now we'll name it to the nightlight. We're naming the layer nightlight. Now what this will do, it will only get the nightlight data within the, sorry, the shapefile is wrong. Deleting the shapefile and kind of shapefile I have. Level 2 boundaries, state boundaries. Let me check the elements. Let's say I have level 2 boundaries and we want to work with Madhya Pradesh. Let's say I want to states, and we want to filter the state to the Madhya Pradesh only. So states, and this time we are going to filter this shapefile. We want to filter the shapefile for the metadata. In metadata, you can see the string name is st/_nm and the name of the states. So sorry, here you can go close, and we will work with filter metadata and state nm, and you can also check here that we have to provide the metadata, name, and the operator and the value. What kind of operator it has, you can check here, that less than, greater than, and like this, and not greater than. So if you want to work with state name, let's say equals to Madhya Pradesh. We have already provided the map layer and maximum stretch. Now click on the, sorry, run. We will declare this variable above this here, and now click this dataset for the MP variable, that is our Madhya Pradesh. Click on the run. Now it should work for the Madhya Pradesh. Our maximum stretch is not correct, so we will check from the visual parameters. We will stretch it to the minimum maximum, and it is giving the range in 0.1 to 5. So 0.1 to 0.5. This is correct? No, 5, sorry. Let's say 6. Okay, now if you click on the run, you can see the nightlight data of VIRS within the map layer. You can change the opacity of the layer from here, and you can check that you can see the larger towns or megacities of the Madhya Pradesh in the bright lights. You can check this is the Indore, this is the Bhopal, this is the Indore, this is the Bhopal, Jabalpur. These are the main districts of the Madhya Pradesh. You can increase the opacity. This is the Bhopal, and you can see the nightlight data. And if you want to add the color palette also, you can same with the same thing. You can add the color palette. in the brackets, like you want to add again maybe yellow and white and orange, red. You can type any colors. For the color palette, you can give. It's not looking nice colors, but you can work. But you can understand that how to change the palettes. This you can perform like this, or you can also delete the color palettes, and you can visualize the data in grayscale in the brighter. So for more things in the Earth Engine, it has a wide variety of applications. You can go through the API documents for the JavaScript basics and Python basics and how to perform the data sets, and you can also work with the example data sets, like if you want to work with the Sentinel data set, let's say if you go to the Sentinel, and you can see the what kind of Sentinel products they have. Sentinel 1 they have, Sentinel 2, Sentinel 5, 3, Sentinel 5. If you want to work, let's say if you want to work with Sentinel 5, you can click on the Sentinel 5, and these type of products are available for the Sentinel 5. Clouds, carbon monoxide, ozone, nitrogen dioxide, methane, sulfur dioxide. Let's say you want to map the concentration of NO2 using Sentinel 5. You can see the data available from 2018 to I think March 2022, and the data provider and the snippet of the Earth Engine code. Either you can click this link for the example data set as a sample data. Here you can see the resolution and the band names. Let's say you want to work with the NO2 data. So we'll click from the first I'm clearing this data, and here we will type the Sentinel 5 NO2. We will get the sulfur dioxide NO2. We'll click on this and we'll import it. And we'll name this variable to Sentinel S5. We can write S5. We can write. And for filtering within the date, we'll first declare the variable, like I'm using same again filtered S5 dot filter date. I want to work with 22 January. Let's say I want to work with January. I want to work. Okay. January 2022 to February 1. January 1st to February 1st, 2022. I want mean of the values of the January, and I want to perform within the which state we choose. We choose, let's say UP I'm choosing this time. So again I have to import the shape file of the states, and we have to filter the states to our UP only. So variable, let's say UP equal to table, because this variable name is table for the shape file, and we have to filter for the metadata state name that we've already discussed. You can see again that this has a string name st underscore name and the state names. So st name comma operator that I want to equals to Uttar Pradesh this time, and hold on, and now I can clip the dataset for the UP only. After filtering, now we can add the layer again with the map. Add layer, we can add the image, we can add the minimum maximum values. Let's say minimum values is 0, maximum 0.2. We will add the color palette later, but for now I'm only adding NO2 for UP. And before that we have to select that. You can see that it has many bands, and we don't want to work with all bands. We want only NO2 column number density band. So I'm copying this band and dot selecting the band, that is NO2 underscore column underscore number underscore density. And here we have mapped the layer in the image. In the curly brackets we have parameters, and we have the name of the layer. You can click on the run, and within a while you can see. Let's stretch it to the minimum maximum values. Oh, let me custom it. I want it 0 to 0.0002. Enter. And you can see the distribution of NO2 over UP within this date range of the January month 2022. And if you want to add color palettes, again you can write like this. Within the brackets you can write the sorry. Say we want to map, want to work with these three colors as a color palette. You click on the run, and it will give the green to the minimum value, red to the maximum, and the white it get the middle value. It get stressed, and if we check what, you can see that NO2 concentration near Delhi and West UP is very high. Kanpur, maybe it is very here. Let's see what this state is. This is near Prayagraj, Mirzapur. It is very high. Lucknow, Kanpur, you can see. Lucknow, Kanpur, you can see that little concentration you can see, and you can explore by, you can play with the numbers. You can stretch it also. Let's say I'm stretching to the maximum. 0. Stretch, and you can play around with the like this also. So this is how you can play around with the functions and the parameters. Before ending, I want to say that you should check the documentation tab. They have created very nice documentations for all the dataset examples and API guides. Everything they have provided very nicely. Get started. You can click, and you can see that they have created examples and explanations for every type of features they have, like in the image collection visualizations that I am discussing very regularly. You can also create the time lapse, and you can create a GIF within the Earth Engine code editor. You can create a web-based app within the code editor. You can perform variety of tasks like this in the what type of visualization you have to give, what type of filters you can perform. You can also filter the cloud pixels like this. This is the name of the metadata, filter cloud percentage, and you can add this is the operator, this is the value. Like this, you can filter the collection. So I am I encourage you to check this documentation tab. Bye for now. Thank you.